Welcome dear learners. Myself Professor Jitendra Sarova from Department of Geography of Dr. Bhimrao Ambedkar College, University of Delhi. Today I am going to elaborate upon theories of the origin of submarine canyons, part 2. In part 1, I elaborated upon three concepts or theories. First one was diastrophic theory. Second one was subaerial theory. Third one was theory of mud flow and landslides with reference to origin of submarine canyons. In this presentation, we will go through three more theories which will try to explain the origin of submarine canyons. This topic is part of Oceanography course of MSc Geography of IGNOU. The first theory in this particular part, second, is submarine density currents theory. Submarines means beneath water, and density currents which develop due to density variations. So submarine density currents theory of submarine canyon formation. Adolf von Sales in 1884, Florel in 1885, and Hahnemann in 1893 propounded this idea based on observations of density currents mainly in lakes, and they suggested this idea of submarine canyons formation due to erosional work of density currents. Buchanan considered density currents as a result of salinity contrasts. Submarine density currents are basically result of temperature and salinity differences. Scholar Daly in 1936 propounded the idea that suspended fine sediment particles produce density currents, and while flowing down the slope of continental shelf and slope through erosion, they form submarine canyons. So this is the basic idea, that submarine canyons are result of erosional work of oceanic water density currents in the submarine environment. The density currents that are used to explain the origin of submarine canyons by proponents of this theory originate due to difference in density of seawater, and this density of seawater varies due to variations in temperature and salinity of the water. Such currents lead to erosion of the continental shelf and slope areas to form huge submarine canyons. However, this theory has not got much support because most of such currents would move parallel to the coast, whereas submarine canyons are aligned transverse to the coastlines. Though density currents are common in lakes and reservoirs, but there is no evidence of their existence in the oceans, where the density stratification of water hinders the vertical flow. Further, the potential of temperature salinity based density currents in erosion and in the formation of massive features like submarine canyons is limited. So on these grounds, this theory was rejected by majority scholars. Another explanation put forward by the scholars is in terms of turbidity currents, that submarine canyons are result of erosional work of turbidity currents operating in submarine environment. Turbidity currents are induced by large amounts of sediments in water, and some scholars have held such currents responsible for the formation of submarine canyons. High level of turbidity sets on such undercurrents of fine material, and they move toward the deep sea, carrying large amounts of sediments downslope on the continental shelf and slope zones. These currents erode the seabed in the continental shelf and slope zones, and this will result into the formation of submarine canyons. So instead of the idea of density currents of water, the idea is turbidity currents. And in case of turbidity currents, chances of erosion are high as compared to simply density currents because they have erosive tools, sediments in turbid water. Submarine currents are observed in many submarine canyons. For example, in Vincent and Mugu canyons as identified by Ritter, and in Huenu Canyon by Trask, and in Congo and Fosse de Cape Breton canyons identified by scholars Lawson and Smith. So there are evidences of association of turbidity currents with submarine canyons. The presence of fine silt and clay sediments at the bottom of canyons provided the ground for turbidity currents based erosion instead of erosion by temperature salinity based density currents. So turbidity currents idea is better than density currents. Due to the presence of suspended fine sediments, these currents are called turbidity currents. Geomorphologist W.M. Davis suggested that oceanward moving hydraulic currents originate because of winds and onshore storms. Once the shore water gains sediment load, its specific gravity increases, and this results into origin of submarine turbidity currents. Such currents produced canyons through erosion and canyons extended up to the continental slopes. Scholar Kuhnen provided evidences that turbidity currents originate on continental slopes due to landslides, as they provide momentum to the sediment and water. The increased velocity increases erosive power of turbidity currents. Once canyons are incised, steep walls increase mass wasting processes. This viewpoint of turbidity currents has been challenged by some scholars on the ground that such currents are rather slow and are not likely to erode the hard rocks of the seabed to form massive landforms such as submarine canyons. Some scholars have also suggested that such currents may be initiated by submarine earthquakes. Evidence in the form of ripple marks on the floor of submarine canyons and sediments fanning out at their ends suggests that these canyons have been formed by downslope movement of sediment and water in the form of turbidity currents. An analysis of the breaking of the telephone and telegraph cables passing through the Atlantic Ocean at the time of 1929 earthquake gave credence to the idea that earthquakes or the overloading of sediments on the sloping ocean bottom may initiate turbidity currents in the form of fast moving avalanches of mud, sand and water downslope on the continental shelf and continental slope. Such currents of debris being carried by water downslope have the potential of eroding the seabed to form deep submarine canyons. A pattern of breaking of the undersea telecommunication cables in a manner like that observed in 1929 has been observed in other parts of the world also. As the flow of debris carried by such currents reaches the deeper parts of the ocean bottom, it slows and spreads out, and the sediments settle there, like they do at the foothills like alluvial fans and alluvial cones. The process of settling of debris carried by turbidity currents forms graded deposits of coarser materials overlaid by layers of material with smaller particle size. Such graded deposits are often called turbidites. Presence of canyons with U-shaped cross-section and flat bottoms of large rivers supplying large amounts of sediments gives credence to this theory. Many gullies found on the continental shelves in many parts of the world also seem to have been formed by downslope movement of loose sediments. So there are evidences, scientific evidences supporting the explanation of turbidity currents. However, Shepherd objected and doubted on the turbidity currents hypothesis on the ground of massive erosive power of these currents required to produce massive V-shaped valleys, that too in submarine environment, that too in hard and compact rocks of continental shelf and continental slope areas. So Shepherd objected to this explanation of formation of submarine canyons through the process of turbidity currents erosional work. So another theory has been put forward by the scholars to explain origin of submarine canyons, and it is based on the explanation of submarine groundwater sapping or springs sapping theory. This theory attributes the formation of submarine canyons to the sapping action of submarine springs bursting out far down the continental shelf or slope. According to this explanation, rainwater percolates into the layers of porous rocks having steep incline towards ocean and seas. In the presence of these outcrops on continental slope, the water gushing out as springs first produces a notch, a small depression, or an opening on the sea bottom, and thereafter the notch develops into a large depression. And through headward erosion, finally the depression changes into a very deep canyon, that is submarine canyon. In this diagram, you can see that at the arrow mark on the continental part, precipitation becomes groundwater and it comes out on the continental slope in the diagram place marked as point marked as A dash. So it comes out as a spring on the continental slope in the marine environment, and at that particular place that small notch or depression develops initially, and which over the period of time will enlarge through headward and lateral erosions into a massive submarine canyons extending up to the continental shelf and slope. As all canyons are not situated in front of river mouths, Bryan put forth the idea of transformation of a notch produced by groundwater shaping on continental shelf or continental slope into a large scarp and its further extension through headward erosion as well as lateral and vertical erosion as a submarine canyon. The groundwater sapping and spring sapping are a natural geological process. The existence of the springs below the sea level is a verified fact. There are many such springs. And the spring flow is like a submarine river flow. And this submarine river flow results into the formation of submarine canyons over the period of time. So surface water after percolation gets stored in permeable rocks as groundwater, and it moves along the slanting impervious bedrocks of continental margin till it oozed out on ocean floor and through the faults, the linear depressions and develop as submarine canyons, and over time dendritic pattern of incision also develops. This explanation of submarine canyon formation is criticized due to conceptualization of dendritic pattern in association with faulted structures. However, general absence of soluble rocks along the shores and presence of strike of the rocks parallel to the present submarine canyons and dominance of cold springs instead of hot springs limits the possibility of submarine canyon formation through solution or erosion action of groundwater or spring sapping. This way, there have been some limitations pointed out by the scholars. According to Johnson in 1939, the submarine canyons may be produced either by erosion or through corrosion. Corrosion means dissolving down. So, dissolving crustal material. Work of submarine springs. Initially, a notch-like depression forms near the head of the canyon on the continental shelf or the continental slope. Over the period, this depression increases in size and shifts backward, or you can say headward, in the form of a shifting valley with steep head and cirque-like appearance. The solution process and occasional mass wasting in the form of slumping and landsliding increases the intensity of incision, and gradually a submarine canyon evolves. It can be concluded from the above discussion that none of the theories put forth to explain origin of submarine canyons fully explains their origin in all parts of the oceans. Say for example, diastrophic theory is able to explain submarine canyon formations in the areas which are geologically unstable, those associated with tectonic and magmatic activities. Likewise, in some parts, subaerial erosion theory is valid, but in some other parts it fails to explain, and contradictions are commonly exemplified. Likewise, submarine weather density currents or turbidity currents or groundwater sapping, spring sapping, we have evidences at some places in support and at many other places against these conceptual explanations. So, there is not a single foolproof theory to explain the formation of submarine canyons. Scholars have applied different concepts and theories in explaining submarine canyons in different parts of the world. While the changes in the sea level and tectonic displacement can explain some of these canyons, the turbidity currents and submarine earthquakes and resultant faulting, etc., can explain some others. So, the formation of submarine canyons is explained by scholars in different parts on the basis of different concepts or theories. That's all. Thank you very much.